Okay, Apes, this is Miss Hubbard. I'm talking about Chapter 8. Please read about hybrid vehicles. Interesting to me because I'd like to buy one sooner or later. I'd kind of like to buy an total electric car. That's page 207, so read that, and let's start on page 208 together. So we know the Earth formed from when the beginning of the solar system, when there's a bunch of rocks and debris, and they kind of solidified into um, one big rotating disk, and then finally the sun popped out, and the Earth, all the dust and debris formed into different planets. It took a while for all that debris to stop moving around the solar system, and finally it did. And we're thinking that happened about 4.6 billion years ago. So as that debris came together and heated up, it formed a big giant clump, and the heavier materials, because they're more dense, went into the center. So the nickel and the iron formed the center, the core. Then we had lighter stuff forming the magma, and then we have the crust of there. So there's 3 parts of the Earth, and we'll do models of that in class. From what I understand, there's not a lot of this information on the AP test itself, so we'll need to know the basics for this class. I think the more important things are going to be for this chapter are the erosion and some of the earthquake stuff, and volcano things. So I think those are the 3 things we need to focus the most on in this class. So this is showing a good picture of the different sizes of the portions of the Earth. So we have the inner core is really small, the outer core is bigger. We got the mantle, which is about the same size as the outer core. Then we got the asthenosphere and then the lithosphere, and we live on the lithosphere. Lith means rock, so excuse me, we live on the outside on the lithosphere. So the very, very top layer, lithosphere. So the asthenosphere, semi-molten rock, and the lithosphere is the hard outer layer. So, interesting guy named Wegener decided that, looking at a bunch of different data, that the Earth was one big landmass at one time, which he called Pangea. And he looked at that from a number of different angles. He saw that there were similar fossils in 2 different land masses. He noticed the shape of this looked like the shape of this. He noticed that there was fossilized plants living, on different continents, and he was going, "Why in the heck is that?" So from the fossils and from the shape, he decided that, hey, this probably was one big landmass at one time, and it broke apart later on. He also looked at different types of rocks. So there was similar rocks where edges touch. So maybe this rock was similar to this rock right there. So he thought, hey, they must be one piece at one time, and they broke in must be one giant piece, and then broke into smaller pieces later on. So that's the theory of plate tectonics. Later on, people said, hey, these plates, there must be even more plates that these land masses are on top of. And so they came up with this theory of tectonic plates. And so if you notice, we live on this big giant tectonic plate. And so this is called, we have a lot of geological activity, so earthquakes and volcanoes and other things. So this is called the ring of fire right here. So they might ask you questions about that. So there's 2 things that are driving these plates moving around. One is gravity, and one is how light or dense the particular plate is. So remember these 3 types of plates. Contacts, there's divergent. Diverge means die means 2, so it's going apart from each other. Con means with, so they're going together. They're moving together and colliding. And then there's transform fault boundaries when two plates are moving. One's going north and one's going south. So we're having this situation in California. We have one plate that's going north and one plate that's going south. And as they bump along each other, there's a lot of energy and friction that happens when that happens, and then we get earthquakes. So this is the San Andreas Fault, the transform fault boundary. So divergent means they're moving apart. Convergent means they're going together, and then one has to slip underneath the other one. When that happens, you're going to have this area melting, and then you can start having volcanoes and other things going on. Transform fault is what we have in California. One's moving north, one's moving south, and as they slip past each other, you have friction building up and things hanging up against each other, and then the earth has to settle itself out, and we have an earthquake based on that. So hotspots are areas down here that have really a lot of magma, and it needs to move somewhere. So this hot magma moves up, and we're going to have all kinds of things going on, like volcanoes and making islands underneath the ocean, stuff like that. So when we have a plate moving over a hotspot, it's going to melt that land surface and cause a volcano. So here's this ring of hotspots right there. This has all been moving and creating new islands of the Hawaiian Islands because of plate movement and hotspots underneath it. Subduction is when one plate is moving underneath the other one, like I just said, and one is melting, and it causes volcanoes on those boundaries. So in California we have some volcanoes, real old volcanoes, because of these boundaries happening, these plates hitting each other or moving past each other. So faults are fractures in rock. In California we have San Andreas Fault. We have other little faults like the Hayward Fault near us and things like that. We have quite a few faults near us, and it's where one big break in the rock has happened because of movement. When those plates have to move past each other, we get an earthquake. So a fault zone is a large place where this movement has happened. It's where the breaking is. The epicenter is the exact point directly above the location where the rock erupts, because the rock is moving next to each other, and that's way deep in the earth. But we talk about where it's happening, where on the surface that location is. That's called the epicenter. You probably should know about the Richter scale. So remember that the math for the Richter scale says if you have an earthquake at 7 compared to an earthquake at 6, that change in number means that it's the energy in that earthquake is happening as a factor of 10. So earthquake at 7, is 10 times bigger than an earthquake at 6. Richter scale 6. So know that Richter scale stuff. It's a log scale. Rock cycle. You might need to know this, but I like it, so we're going to learn about it. But I hear there's not a lot on the AP test about rock cycle. So rock cycle is just you're having rocks formed and destroyed all in this rock cycle process. So when you have hot magma, it's going to get to the surface of the earth somehow, and it's going to become igneous rocks. Those igneous rocks are going to weather, and little bits and pieces are going to be transformed and moved somewhere else. When they get compacted down, they're going to turn into sedimentary rocks. And then if they get moved down below the surface and they get heated up a little bit, they're going to turn into metamorphic rocks. And then finally they're going to get hot again, liquefy, and come to the surface and become igneous. So it goes around and around in a circle. Rocks are made out of one or more minerals, and minerals are just crystals of a particular chemical. So know the difference between a rock and a mineral. Rocks can be formed from one or more minerals. Minerals are a particular crystal chemical. So that's pretty much what I just said. So look at that for a sec. So weathering happens due to wind going across the surface of some rock or by water breaking it down. So that's physical weathering. Some chemicals can weather rocks as well, and some biological agents like a tree roots can break through rocks. Chemical weathering is happening like in the top of in a cave where water is dripping. It can actually dissolve chemicals and turn it into stalactites and stalagmites. Erosion is physical removal of rocks based on wind, water, or ice, or living organisms. They can erode things, and then they can deposit it somewhere else. After the wind dies down, it's going to deposit in an area, and then over time it can turn into a sedimentary rock. Okay, that's the end of this section, so I will do the next section starting on page 221 for part 2. Okay, talk to you later, apes.